Okay, I start the lecture. So this time we will talk about solid waste treatment. So I don't know if you have seen this animation before. So it was a world where human beings abandoned the planet Earth and they all left. And then what's left behind is a lot of garbage, a lot of rubbish on the surface of the planet. And this robot is left behind to deal with them. Okay. It's very good. So if you have time, go watch it. Okay. So so this is showing you the Maldives. So the country in the Indian Ocean. So what your first impression of this country usually, of course, is beach and vacation, right? So usually it's very nice, but actually, so this is how they deal with the rubbish problem. So they don't have a sanitary landfill. They just dump their garbage over an island here. Look at it. Okay, so it's very close to their capital. So the capital is over here. You can see that. Okay. So back in the year of 1987, so there was something happened in the US. So what they have is a ship full of garbage. So it's a lot of them. So 3,200 tons of trash, okay, from a city called Islip here, this one, okay, in New York, and it's trying to dump the garbage somewhere. Of course, not in my backyard, right? That's what we say about things that we don't want, not in my backyard. So they want to transport that away and hoping other city would receive that. And they look for different cities along the coast, and nobody wanted that, of course. So 6,000-mile of voyage. And then finally it reaches another country here. So, and they all refuse. So Mexico refuses, of course. They don't want that, right? It's 3,200 tons. So after that, they went back, and the only city that would accept that it's their own city. Okay, the trash was incinerated, so the trash was burned and buried in the same city, which first rejected the trash, right? So the hope is to make it go away. So every day we make waste, right? So where do they go? Okay, so this is a flow chart showing you the so-called material flows. So the idea behind this is to study where the material where does the material come from and where do they go after we have used it. Okay, so here the materials are extracted. So materials in your phone, materials for your clothes, and your desk, your chair, so everything that you're using, they are extracted from the mother nature. Okay, of course some part of it is imported, and then you use it, right? Material used in here. Okay, and then after that, of course, you will dump that, right, to the landfill here, and some of the waste is exported because maybe some countries would want to recycle material, right? Okay, and then you recycle a part of it. So you are using 4.5 billion tons of material each year, but in the European countries, they only recycle 0.7, so not a lot. Okay, a part of it goes to the landfill, a part of it is incinerated, is burned. Okay. Okay, so what's the definition of waste? So something that we don't want, unwanted, unusable material and substances, right? So it's very subjective. So some people might think that, okay, this is a waste, but another person might think that it might be useful to me, right? So we need to differentiate between waste and resources sometimes. So that's where the recycling idea is coming from, right? Sometimes we can recycle things that are not useful to other people. Okay, so our government is setting a 10-year reduction target by 40% is not happening. I can tell you that. Okay. Okay, so we have different categories of solid waste. So here we mainly talk about solid waste, right? If you talk about liquid waste, like water, sewage, we have talked about this, right? Or for the water quality control lesson. So this time we talk about the solid part, municipal solid waste. So so this is like a total of everything, all the solid waste together. So the term is MSW here. So it includes different things. Domestic, which means that it's the trash coming from our house. Commercial, maybe coming from some big malls or shops. And then industrial, coming from the factories. Okay, and the categories that are not included in MSW would be food waste and construction waste, chemical waste, clinical waste, and cooking oil. So maybe a lot of them coming from the restaurants. Okay, and other special waste in here. So maybe, okay, radioactive waste may be coming from the lab, and also sewage sludge. So this is coming from the water part of the waste, right? But if you have filter, so we remember that at the end of the water quality lesson, we have the water quality control, right? We control the water quality by turning the impurities into solid, right? And then we scrape it off on the bottom of the tank. So that would become solid waste, right? Sewage sludge. We have a sludge facility in Hong Kong. It's called T Park near Tuen Mun. Okay. Okay, so this is I have tried to find some recent numbers, but this is like the most recent one that I can find online. So the recent annual global municipal solid waste generation is around 2 billion tons per year for all human beings. Okay, and if we do the average, 7.4 billion people for the year 2016, and then 365 days, and then it would be around 0.7 kilogram per person per day. So every single day we are dumping this much of trash. Okay, so the average actually over different countries it would be different. So it's around 0.11. I'm wondering which country this is. And also 4 point something kilograms. So that's a lot, right? Above the average. So here I have a graph showing you the projected waste generation. So by projected, we are talking about the future, right? We're talking about the yellow and the red one. And of course, for the East Asia, for our basin, for our area is like the most because we have the largest population, right? And we are projecting to have more and more trash, more and more solid waste in the future. Okay, so this is showing you in descending order of the amount of MSW, the solid waste generation per capita means per person. Okay, so kilogram per day. So in Hong Kong here, we are in among the richest countries, right? And we're not a country, but this region, the GDP and also the amount of municipal solid waste is among the richest regions in the world, right? Different regions here, maybe United States. I don't know what's happening in Mongolia. Okay, it's a lot of waste. So I've separated them into 3 groups. So the first group a lot, above 2, and then the other group is in between. And then some countries they just can reduce their solid waste to a very minimal amount. So for Japan, it's 0.95. I think they are depending on their use of incinerators. So they burn everything anyway. Okay, and then that would reduce the weight. Okay, so this is a graph showing you the change over different years for the municipal solid waste and domestic waste. So I have just said it. So municipal solid waste here, which is the blue one, it includes everything, right? It includes domestic waste, commercial and industrial waste, right? And a part of it is coming from our home. The red one is coming from our home. You can see that it's relatively steady. So our increase is might be coming from the commercial part, right? We have more and more big malls, more and more shops, more and more commercial activities, and they would throw away waste, right? So it's not something we can control. Okay, so here I'm showing you the bar charts of different parts of the waste. So domestic waste, again, the red one is coming from our home, and the blue one is coming from the commercial part. You can see that it's expanding. Maybe it's also related to the economic activities, right, in Hong Kong. We have more and more tourists, right? We have more and more people walking around on the streets, buying things and going to restaurants. Okay, so that's the blue part. And the orange part it's very different comparing to the 90s, because it was the time where we have a lot of infrastructure development. So the large bridge connecting to the airport and our airport right now. So they were building that in the 1990s. So a lot of construction waste. Okay. We are seeing a relatively stable, I would say. So the orange part is relatively stable. Okay, and other special waste is just little amount. Okay. Oh, this is just for your reference. Okay, Python script for drawing this. Okay, so we had talked about this. The municipal solid waste is around 71%, and the second largest part would be the construction waste. Here, 25%. So that's why the government would be charging you if you are having like some little renovation in your house. You will have to pay for that waste because it's construction waste. Okay, so if we separate the solid waste into different categories, so we have different categories here, right? The glass, the metals, paper, plastic, food waste, textiles, so clothes that we throw away, it's a lot. Okay, and wood, and this one is household hazardous waste, so something that would smell. Okay, give you the VOC. Okay, and the total would be this one. And you can see that, okay, every time when you work on something, you look for the largest proportion, right? Largest component in that element. So what's the largest component? It would be paper, plastics, and food waste. So that's why the government is really working on these, because if you can do a lot of recycling, you can reduce the total amount, right, by a lot. So they're building facilities for collecting food waste. And also we have some collection ponds in different districts in Hong Kong to collect the plastics. And of course, paper, right? We have been doing that for a long time. So, so this is a bit of the history for Hong Kong. So, I don't know if you know about this. So a very large part in the coastal area is actually made by reclamation. So we have filled the ocean up. So the gray part is originally it was originally the ocean. Okay, and this is where we used to dump our garbage. So it's called Jean Drinkers Bay. 最早灣 here, this one. Okay, so if you know about the history of Hong Kong, I think in World War II, I think you might be familiar with this name. So so you can see that it's a nice bay. So very, very convenient to dump your waste into this Drinkers Bay. So this is one of the way that people use to deal with waste, or they would take the waste, put them on ships, and then dump that into the open ocean. So another way to do that would be this one, but this one is closer, right? You can just put your garbage on a truck and then dump them here, right? So so after a while, people turn that into the landfill because it's already filled up, right, with the garbage. Okay, now it's a park. It's not open yet. they didn't say the reason. Maybe it's still releasing some toxic substances out of the surface, right? This is a nice part, right? But how come they don't let us use it? So might be the reason. Okay, so for the ancient time, how did people deal with their garbage? How did people deal with their trash? They just find a site and then dump their waste there. Okay, open pit dumps. So the trash is not covered, unregulated, so no regulations whatsoever. And of course, many toxins were dumped, and the toxins would go into the environment, right? You have underground water, you have rain, right? So that's not good. We also, so the two modern approaches to deal with the garbage is, the first one is incineration. So the waste is burned under control conditions. And why do we burn the waste? We can reduce their volume to 1/10 of the original volume. So we can save some space, right? In Hong Kong, we don't have enough space. That's the biggest problem we have here. Okay, so incineration probably is a good idea, but nobody wants that. Again, not in my backyard. Okay, so it looks like a very ancient photo because it is ancient, right? 1968. So people used to have the incinerator in Kennedy Town. It's hard to imagine today, right? Okay, and then the second one, so this one is what we are doing right now, is sanitary landfill. So it's like dumping your garbage into the landfill, but it's called sanitary because we have some modern methods to make it clean and then make it controlled. It should be in a under control conditions. We'll talk about this in this lesson. Okay, so I think I have already talked about this previously. So before you build this kind of incinerator, you have the chimneys, right? So maybe so this is what we call environmental impact assessment, right? We need to study the wind direction, the strength, and then the wind direction at different heights. And then we would know if your chimney is high enough. Maybe, okay, if this is the situation that you have most of the times, the right graph on the top here. So if this is the situation, you probably need your chimney to be higher than this level, right? Higher than this dashed line, so that your plume would not do the downward mixing, right? It would be higher than this dashed line, and then the smoke would not come down to the surface, right? You're living on the surface. Okay, so this is why we need to study the wind before we build anything. Okay, so what's a sanitary landfill? We try to control the biodegradable fractions of the organic part that were degraded by the bacteria, right? We have talked about this. So the anaerobic decomposition, right? So by the bacteria, so the bacteria would do the degrading, right? And after that, what would appear? We hope that all that's left behind is the inert solids that does not react with the environment. Landfill gas, this is unavoidable, right? And landfill gas, we'll talk about that. And liquid leachate, so it's like the sewage coming out from the landfill. Okay. So we have different problems coming out from the sanitary landfill, even it's called sanitary landfill. We have limited landfill space, and the nearby water body would be contaminated by the leachate. So if you have leaking of the sewage coming out from the landfill, that would contaminate the environment, right? That's not good. And also pollution from the landfill gas, mainly it's methane. Methane is one of the greenhouse gases, right? So different environmental problems coming out from the sanitary landfill. And also for incinerator, of course, you're burning things, right? So we are trying to look for the part where we can burn combustible fraction of the waste. And hopefully that will turn to energy, right? We can use that. And combustion gases, so different gases, right? When you burn things. And then ashes, we have to deal with them exactly the same as the electricity generation plant. Okay, The problem, of course, is atmospheric pollution, right? Okay, so what's a sanitary landfill? It's not an open pit. Okay, it's not open. You can see that they are all closed unless, except for this one working cell. Okay, and the solid waste is compacted to the smallest volume. So we want to reduce the volume to as small as possible because we want to save space, right? So that's why waste, the first step to deal with waste is to do compression, right? Compact the solid to a very small volume, okay? And waste is spread in the landfill. So the goal here to build this is like a mountain, right? It's very high. So the goal here is to make it stable, not collapsing. It means that it should not be in a structure where it would collapse, right? If it has collapsed, then what everything that you work for, it doesn't mean anything, right? You want to cover that. If it has collapsed, then it's not covered, right? So we try to put on a cover material, which is soil. So that's also very environmentally unfriendly because you need to find the soil somewhere, right? The soil are put on the waste to prevent access to so we don't want other organisms to be in contact with the waste, right? There might be some food there, right? There might be something that's eatable, right? Birds, insects, rodents, we want to put the cover to prevent the access of these. Okay, so here, before we put the garbage to the landfill, we need to do some waterproof treatment to the bottom of this landfill, right? We don't want the leachate, the sewage from the garbage to go into the real soil in the world, right? And then that would be leaking to the underground water, right? We'll go into that later. Okay, so different consideration for landfill site. Of course, environmental impact, right? We had just talked about this. So location of groundwater aquifers. When we look for a site for the landfill, we might need to look at the groundwater situation, right? The soil conditions and the nearby ecology, are we going to affect the ecology nearby, right? So another thing, so very important thing to consider for the waste treatment is transportation. So do we have so every single day for every one of us, if we create 1 kilogram, that's a lot of material transfer, right? Every single day we need a lot of trucks. We're talking about a very large amount of trucks, right? To do the transportation. So you need to build the roads, the transportation, the traffic to access to the landfill, right? So we need to do this every single day. So the traffic might be congested because you want to transport the waste away. So if you watch some TV series about the Armageddon, the end of the world, the first thing that they would show you in the TV shows, first thing they will show you is garbage on the road, because for our modern life, we rely on this, right? We want people to come and get our waste, transport that away. So remember the COVID-19, right? When we were having that, everyone is staying home and the garbage is a big problem because of this transportation problem, right? So neighborhood, so probably the landfill is next to some residents, some people living there. So we need to care about this. Okay, so this is nearby neighborhood. So we have a southeast North Territories landfill here. So there's a sanitary landfill here, and you can see that it's very close to where people live in here, right? There's even an empty house station. So that's why these people there's a possibility that these people would smell the thing coming out from the landfill, depending on the wind direction. Okay, so there are different so-called strategic landfills in Hong Kong. So the 3 largest one is, we just talked about this, the Southeast New Territory, Northeast New Territory, and the West New Territory. Okay, 3 of them. And they are different. So I'm showing you the properties of one of the landfills in here. So area, location, and one thing to remind you is the height of the filling, right? 170 meters. So imagine 170 meters thickness, the thick of garbage building up from the ground, right? That's a lot. Okay. So different environmental issues we need to care about for this waste management. So we are dumping the waste. So first of all, we look at this carbon inputs. So we're dumping the waste that would contain the carbon, right? The carbon would somehow go back to the atmosphere. So this is greenhouse gas release, right? And also because of the anaerobic decomposition, you will have CH4, the methane, building up inside the landfill, and then you release that back. Some of them would escape, right? Release that back to the environment, also a greenhouse gas. And also another thing we need to care about is the leachate, the leaking of the liquid, right? The sewage from the landfill. They have a special name, it's called leachate. Okay. And you will have to also collect this because you don't want this to be leaking to the environment. So two things we need to deal with: the liquid part that is leaking, also the gas part, the gaseous part, right? The CH4, and it's flammable. It could be dangerous. Okay, so how do we deal with the leachate? So if you're having the anaerobic, so if you're having a very primitive landfill here, you have the solid waste and the water would be going down, right? So there's a leaking of the sewage, and then it would sink to the bottom, right? And then go into the environment, just like this cartoon showing you. So going into the river stream, going to your crops, and you don't want that. So what we do is we put an impermeable layer on the bottom of the landfill, and then we will have the leachate building up on the bottom, and then we will build the pipes to collect them. Okay, so this is an anaerobic sanitary landfill. Even if we have leachate, we have the collection system. Okay. So for the leachate is actually a liquid part. So you have already learned about this, right? How do we study the water quality? So the first thing that they study is BOD5. Yeah. So the new landfill, if we are talking about the new landfill, the BOD5 is very, very large, the number. Okay. And if it's a mature landfill, if it's already buried for 10 years, the BOD5 would be much smaller, which means that the organic material is decomposed, right? A lot of them is decomposed. And there are different properties in here. I'm not going over them one by one, okay? So how do we put down the impermeable layer to prevent the leakage? So we have 3 layers. So this one is the original picture from the book, and I've simplified this one with the 3 layers in here. So the first layer is the clay liner. It's actually soil, but it's compressed soil, okay? Because the surrounding is soil, right? So you want to have like similar material next to that, okay? And then in the middle, you have the synthetic layer. Synthetic layer is this one. Synthetic layer is very thin. Okay, the synthetic layer is the impermeable part. It's supposed to block the water from going out. So it's supposed to block the leachate from going out. And then another on the top, which is the sand. So inside this layer of sand, we have the pipes collecting the leachate. Okay, it should be permeable, right? The water should go through, and then we collect the leachate and transport that away. Okay. So this is a picture showing you that the area of the landfill is covered by impermeable liners. So we also have the leachate treatment plant. So we collect the leachate and then we have to do water quality control. Okay. So for the 3 layers, we have different properties, right? For the upper one, the sand, it should be highly permeable, allow the water to go through. So the orange one here, and then we collect the leachate with the pipes. So the hydraulic conductivity is large. So what's the hydraulic conductivity? We have talked about this in lecture 8. So that's the K here, hydraulic conductivity. If it's higher, then you have higher flow rate, right? It's more permeable. Okay, and then the middle one is impermeable. So this is the layer we rely on in preventing the leakage of the leachate from landfill. So the hydraulic conductivity is very, very small. It means that it's practically impermeable. Water cannot go through. So very 10 to the power minus 12. Okay. And then the next one is just the soil liner. So it's supposed to protect the synthetic layer, right? So synthetic layer probably is plastic, right? The geomembrane is probably plastic. And if you don't want the rocks and the hard materials in the original soil to damage this synthetic layer, so you put in a soil liner to separate the synthetic layer and the original soil, right? Okay, this is just a revision. So I pulled this off from the EPD website, and so this is a graph showing you what they're doing. So they have probably not just one layer of impermeable liner, they have different layers to prevent the leakage. And then they have a system collecting the leachate, right? The landfill leachate, and then they have a landfill treatment plant. And then they do the water treatment, just like what we talked about, the water quality control, right? And then we can dump that back to the sewage system, the public sewage system. Okay, so this is a flow chart showing you how we deal with the leachate. So this is a water quality control graph. First of all, we have the metal precipitation system. So we deal with the heavy metal inside, okay, by precipitation. And then we will have the biological treatment for the removing organic pollutants and also ammonia. So we had talked about this, the ammonia stripping plant. We talked about this in lecture 4. So we try to remove the ammonia in the water. How do we do that? We drive this equation to the left-hand side, and then we want ammonia as much as possible because it's less soluble. And we can collect that, right, if it's solid. Okay, so ammonia stripping. So how do we do that? So this is a graph showing you how we do that. So we have contaminated water, and then we will have this chemical reaction going through inside this ammonia stripping plant, and then we will have clean water out. So in lecture 4, we also talked about this. So raising the pH of the water helps. So in the tank here, we probably try to raise the pH value. Okay, so next we talk about landfill gas. So it's very simple. So CO2 is not toxic, right? It's just you don't care about that, and we cannot use it as a fuel, right? So, but for methane, it's a different story because we can generate power. We can burn the methane and generate power. So usually we have the collection system in the landfill, and then we will have the treatment of this methane. It might not be only methane, right? Might have other impurities. So we treat that, and then we try to use the energy there, right? And then electricity power generation. Okay, so most of the landfill gas, around 45 to 60% is methane, and the other part, largest part would be carbon dioxide. So we just care about these two most of the times. So this is a revision for lecture 7. You can see that for the decomposition happening in the presence of oxygen is called aerobic decomposition. So the things that are coming out would be normal smelling, okay, CO2, water, and stable products. For anaerobic decomposition, it's going to release some unstable products. They usually smell. So that's why if you are closer to the trash, the garbage, you would have some unpleasant smell, or you will sense some unpleasant smell that's coming from that. So anaerobic decomposition. So why do we have this revision? Because you can imagine that in the pile of garbage in the landfill, it's going to be anaerobic, right? So this is a timeline here. The time X is time and Y is the amount of different things inside the landfill. So first of all, at the beginning, you have the aerobic stage, so stage 1. So you still have some oxygen left. And so at time equals to 0, it's the time where the wastes are placed in the landfill. And of course, the oxygen would be depleted, right? You have anaerobic conditions begin after a while, and then you will enter the second stage. So this is just showing you. So I'm not familiar with the biology here, but a lot of things happen inside the landfill. So the microorganisms are doing a lot of the decomposition jobs for us. So you can see that different types of gases are coming out from the microorganisms. So for your reference here. So that's why you're seeing different amounts of the gases in here. Okay. And then of course you have decomposition, right? You have increase of CO2, and you have different decomposition from the bacteria that will release hydrogen, carbon dioxide, fatty acids, and alcohol. So I've shown you some of the things here. And also simply organic acid. So acidic stage is the stage 2. And because it's acidic, you will have heavy metal released from your garbage. Okay. And then in the third stage, you will have a large amount. So we had talked about this, right? So the largest amount would be CO2 and methane. So this is the stage where you have the maximum amount of CO2 released. And also it's anaerobic, right? So methane is going to come out from the bacteria. So I've shown you so you can see methane in here, right? CH4. Okay. And then after a while, after a long time probably, okay, and you will enter the steady state, you will still release CO2 and methane, but it doesn't change with time, okay? We are hoping to, if you're reaching this state, it would be easier for management, right? You know how much it's releasing every single year. Okay, so we need to extract the methane because it's flammable, right? It's dangerous. We extract that and then we try to burn. So sometimes people just don't use the energy. They just burn that right away. But in Hong Kong, we have full operational landfill gas collection system in the year 2020. And there is, so 10 megawatts is not a lot, but still you are making use of the energy, right? Stored inside the landfill. Okay, so this is safe and already closed landfill in Hong Kong. I don't know if you have visited this park before. So a lot of people doing picnic there, Jordan Valley Park. Actually, it was a landfill, so that's why you see a very large area of nothing, and people are not crazy in having buildings there because you cannot build anything on top of the landfill, right? You can just use it as parks. Okay. So they have of course, they have made sure that it's safe to go there because we had talked about this, right? So they release the garbage release toxic material, CH4, different things into the environment. So they have to be in a steady state. So if you keep your landfill in a sanitary way, you will reach the steady state sooner, right? So they control the gas emissions and they control the odors. Of course, on top of the waste, you still need an impermeable layer again. Okay, so you have impermeable layer on the bottom, and then you have the impermeable layer on the top because you don't want anything to come out, right? But one thing to bear in mind is that we have heavy precipitation in Hong Kong, right? We try to prevent the rain to go into the landfill to become leachate, right? We don't want that. So on top of the waste, we have a base layer of soil to protect any infrastructure in here. So we have the gas collection layer. We don't want the waste to affect this layer, right? So we put some soil in between to protect this layer. And then we have the hydraulic barrier layer, so very impermeable layer, so to prevent the water from going in. And then we have the layer where it is permeable, so we can collect the rainwater. Okay. So this drainage layer is trying to protect the barrier layer from the freeze thaw damage. So what is that? So if you have some small damage to your barrier layer, and then you have water going in, right? So this layer is impermeable, so water going in. And then if it's too cold, it's deep down under the soil, right? Sometimes it could be below 0 degrees Celsius, right? And you have ice, and then because the ice would expand a little bit and your damage would become larger and larger because of this. Okay, so we don't want that. So we have another layer to protect that. And then on top, another layer of soil or cobbles is the kind of rocks that would allow water to go through, right? The water go through this protection layer, and then you can collect the water at this level, at the drainage layer. And then on top, of course, sometimes you would have some grass, right? You can see the picture here. You have some grass. So have some soil here so that you can grow vegetation on the top. Okay, so I had talked about this Gene Drinkers Bay landfill, right? The first landfill that we have in Hong Kong, and it's still not open. It's not open yet, maybe because back then in the 1960s they didn't have very good management for the landfill, so that's why it's, they didn't say, but that's what my guess is. So maybe some toxic materials are still coming out, so they are not open to the public. Okay, so we want very good maintenance of the landfill even after it's closed, because we want to use that space, right? So sometimes we turn the landfills into parks, playgrounds, or golf courses. Okay. So a lot of closed landfills in Hong Kong. So this is what we talked about, the Gene Drinkers Bay landfill. There are others. So this one is turned into a golf driving range. Soon one. Where is it? Okay, here. Okay, so we can estimate the volume that we need in a landfill by this equation. So the volume on the left-hand side, P is the population of that city, E is the ratio of the cover soil. So you can imagine how much soil we need every single day to cover the landfill. Okay, ratio of cover soil and the landfill or the waste itself. So the ratio here is 1.9. Okay, so one part of the solid waste, we need 0.9 of the soil. So that's a lot of soil, right? Every single day. Where does it come from? I think we have to buy some of the soil from overseas. Okay. Okay, and C is the average mass of the solid waste collected. So it's from statistics, right? Every single day, how much we are dumping. And the density of the compacted field. So if you have compressed your waste, what's the density of that? Okay, so this is like a rough estimation on the volume of our landfills. So in Hong Kong, this is an estimation of the population, and let's say each person is dumping 1 kilogram of solid waste each year. And how much space is needed for 20 years of operation? So the ratio of the cover compact field is 1.9 here. So I'm showing you a small diagram in here. 1.9, and the density of compacted waste is, so this is the density of the waste. And we put in different numbers, plug in different numbers, population, amount of MSW each day, and then 365 days a year. And 1.9 is coming from the soil cover ratio. Okay. And D is the density of the waste. And we have compressed, so the compression rate is 4.5. So for every 4.5 unit of waste, we compress that to 1 unit. Okay, this is the idea. Okay. And then we find out each year we need this volume and then multiply by 20. So this is a huge amount of volume. So what assumptions are made here? The assumptions are that we are not having a growing population. Of course, if you just multiply by 20, it's not good enough, right? And also we assume every single day we are just releasing 1 kilogram. It's not growing, it's not decreasing. It's not true, right? So we have to check. It's not 1, actually it's 1 point something, right? And it's increasing over years. So I have found different reports from over different periods of Hong Kong. So EPD released different reports. Every single time they say that, okay, the landfill is full. So in the year 2005, this is what they released. So they're saying that it's almost full. And I think this report is released in 2013, and they're saying that it's almost full. So the brown part here is the part that we have used, and the remaining capacity is the rest of the bar. Okay, this one is almost full. Every single time they say this, but we're still using the landfill to this day. Okay. We have expanded the landfill. So in Hong Kong, it's a serious problem, very pressing issue. Okay. So this is the target. We want to reduce our 1.3 kilogram to 0.8, and it's not happening, right? So 1.3, now it's 1.5 or more, okay? So that's why we are building the incinerator in Hong Kong. Okay, maybe we can take a break for 5 minutes. Okay, let's continue. So so this is the number or the amount of domestic waste that we put to the landfill at 1.5. Okay, almost 1.5 kilogram per person per day. So how do we deal with that? So another suggestion in Hong Kong would be having a law. So having regulations on the volume. So we are going to charge people. So I'm sorry, this is in Chinese, so I cannot find anything in English. So so this is an example comparing different cities in the world. So in Hong Kong, this one, municipal waste, solid waste, and in Taipei City, they have reduced their solid waste to a very low amount, 0. something, even 0. something kilogram, because they have implemented a volume-based waste fee system. So they are charging people with the amount of waste they are throwing. So you can see the successful case in here. Also in South Korea, they tried to do that in the year 1995, and they have been reducing their amount since. Okay, so another way, so we have talked about it, another way to deal with the waste, the solid waste, is to burn them, right? We have different incinerators in Hong Kong. We used to have different incinerators in Hong Kong. So Lai Chi Kok, Kennedy Town, so different things, and they have all stopped their operation in the 1990s, probably because of the air pollution problem. So people have been very aware of this. And now the government is proposing to have an incinerator again, but this time is not like this old style, right? It's very, very old style. So what they are suggesting is that we still burn the solid waste, but we will use the energy, right? We use the energy, and also the flue gas in here, the middle part, the flue gas, it will go through the treatment plant. The flue gas will go through the treatment plant, and then we will deal with the toxic material, toxic gases inside, and then we put that back to the environment through the chimney. Okay, so and the modern one should be less of a problem in terms of pollution. Okay. So one time when I am done with some soda drinks, I try to wash it, and then I would try to recycle that usually, right? So my friend asked me a question. So are you thinking of the resources that you're using when you recycle this stuff, right? When you recycle things, you still need to use energy, right? So is it helping the environment, or if you are using way much more resources to deal with the recycled material, right? It looks very, the recycling idea looks very good, right? But you still have to use resources. So how do we balance between these two? So here I'm showing you the waste management in terms of the greenhouse gas emissions. So let's say if you have extracted something from the environment and then you use it, right, in our everyday lives, and then in the process sometimes we release greenhouse gases, right, and reduce carbon sequestration in the forest because we use some of the material, right, from the trees. So the column here is showing you the greenhouse gas emissions throughout different stages in here. And of course, we use energy, right, through the manufacturing, and then we use it. Let's say it's paper. Okay, the manufacturing of paper, and then you use it, right? And some part of it is not usable again, so you throw that away. So it goes to waste management, right? And some part of it goes back to recycling. So in here, if you do the recycling, you are releasing CO2, and then you are increasing so why do we increase the forest carbon sequestration when we do recycling? because if you do recycling, you are not using the new paper, right? You're using old paper. So you are trying to help the forest because of that. Okay, and then some part of it is thrown away to the waste management, and then in the process here is you have decomposition, right? Decomposition of the paper, and then you release CO2 and some part of the carbon. So there's carbon in the waste, right? Carbon is stored back to the soil, so it's buried under the landfill, and you're hoping that this carbon is not released back to the environment, right? Sink. So in this column, you are helping the environment by putting the carbon back to the carbon sink, right? So combustion, when you burn that, of course, you release CO2. But if you burn the waste, you will avoid using fossil fuel, right? So this column is helping the environment, and this column is releasing greenhouse gas. Okay. And landfill, of course, we are releasing methane as one of the greenhouse gases, right? So this is a careful study, a careful calculation on the pros and cons of dealing with the materials in here. So recycling part and also the landfill incinerating part. Okay. So the first thing to talk about here is the fossil fuel combustion emission. So when you transport the materials, maybe if you buy a clothes, buy a shirt in Uniqlo, so they have transported that shirt to you, right? So they have used energy. In the process, they have released greenhouse gases, right? Transporting, making, and disposing the products. Okay, and then the second category is non-energy related manufacturing emissions. Okay, so it's talking about industrial. So in the industrial world, some of the manufacturing process, they might release CO2 into the atmosphere. Okay, so in the landfills, you have methane emissions, right? And also other types. So from the waste combustion, from the incinerator here. So also we need to talk about the carbon sequestration. So all the processes, some of them would help the environment by storing the carbon back. I've talked about this already. Okay. So one column is carbon emission, one column is carbon sequestration. Okay. So how do we turn everything in here? So there are different things in here. How do we use just one unit, one type of parameter to describe everything in here? We turn the emissions and the things into so-called equivalent carbon emission. Of course, the carbon sequestration part would be negative, right? And the carbon emission part would be positive. Okay. And for example, how do we change the methane into carbon emission? Methane is not carbon dioxide, right? So we have the so-called the global warming potential. So we use one as the global warming potential of carbon dioxide. And if you're releasing 1 unit of methane, you have to multiply the whole thing by 23 if you're talking about 100 years of time frame, because the warming effect coming from methane is so much larger than, so we're talking about 1 unit, the same amount, okay, comparing to carbon dioxide, because it absorbs more heat. Okay, so it depends on the heat absorption ability, the concentration of methane, and also half-life. So it's become smaller and smaller over a long period of time because it reacts with the environment, right? So this is a table for your reference. So I've just taken this 23 number. So the 100-year global warming potential methane is 23, which means that 1 ton of methane is equivalent to 23 tons of carbon dioxide. So how do we turn different things in here into equivalent carbon emission? This is an example. So it turns out that we can reduce the greenhouse gas emission. If we compare recycling and landfilling, so if we do the comparison between these two, if we recycle aluminum cans, we can reduce the carbon emission by 3.71 metric tons of carbon equivalent per material. So if you use 1 ton of aluminum cans, the recycled aluminum cans, you will save this much of, we reduce this much of carbon released to the environment. Okay, and you can see that all of them are almost positive numbers. If it's negative number, it means that don't do this. Okay, don't. For example, this one, if you burn it, it's better to do landfill instead of burning. So if you burn that, it's not helping you to reduce carbon emission. It's actually increase the carbon emission, because the numbers here are talking about reduction in carbon emission, right? So if it's negative numbers, release of carbon. Okay, so don't burn the aluminum can. So it means maybe we should do landfill instead. Okay, so the numbers here are smaller because it's not recycling, right? Recycling, you might have a larger effect on the carbon emission. Okay, so this is just showing you the idea behind. So if you compare the recycling and landfilling, maybe if you do landfilling and if you do recycling here, you will reduce, for example, reduce the energy of extraction, right? You don't need energy to do this anymore. Maybe you will use some energy in the recycling process, but it will be less than this one. So if you compare these two, you understand why we have such a large number in here. So save some carbon emission. Okay, so this is an example for, I think this is the last slide. Okay, this is an example for recycling the materials for an airport. So every year they recycle different amounts of things. So aluminum, cardboard, office paper, newspaper. So we use the table shown here. So this column. They're asking you how much greenhouse gas emission we have saved, we have reduced by recycling the material in here. So it's a lot, right? So if you 12 tons of aluminum multiplied by 3.71 metric ton of carbon equivalent, okay, per 1 ton of aluminum. So this is how much. So we have added everything. So that's a really good result. Okay, if you do recycling, you will help reduce the carbon emission to the environment. Okay, so that's it for this lesson. Okay, any questions? If not, then see you in the tutorial.